Hi, let's understand another very important concept of this chapter, that is number of elements in a set. How many elements are there in a set basically? So if we take a set in roster form, that is set A, whose elements are 1, 2, 3, 4, 5, and if we just count how many elements are there, so we can observe that there are 5 elements. Now this can be written as number of element in set A is equals to 5. So n means number of element, A is nothing but a name of a set, and 5 is how many elements are there. So we read it as number of elements of set A is 5. In simple terms, we can also read it as n of A is equal to 5. Let's take one more set B, whose elements are 4, 5, 6, 7, 8. Again we can observe that 1, 2, 3, 4, 5, there are 5 elements. It can be written in mathematical form as number of element in set B, that is n of B, is equals to 5. Now let's take intersection of A and B. We know that intersection means we have to write only common element of set A and set B. So if you observe set A and set B, we can observe that 4 is common as well as 5 is common. So we write A intersection B as 4, 5. That means if we just count, there are 2 elements. So it can be written as number of elements in A intersection B, that is n of A intersection B, is equals to 2. Now let's take union of set A and set B. So A union B is equal to, union means collection of all the elements without any repetition. So A we have 1, 2, 3, 4, 5, and from B we have 4, 5, 6, 7, 8. But we know that 4 we can observe 2 times and 5 we can observe 2 times. We have to write only 1 time because repetition of element is not allowed. So we'll write 4 and 5 only 1. So we get 1, 2, 3, 4, 5, 6, 7, 8. That means there are 8 elements. So we write number of elements in A union B, that is n of A union B is equals to 8. So what we have calculated? We have calculated n of A, n of B, n of A intersection B, and n of A union B. Now let's see some relations between all these, right? Now do one thing. We'll take n of A plus n of B and we'll subtract it with n of A intersection B, and let's see what do we get. So n of A, we can replace it with its value, which is 5, plus in place of n of B we can substitute its value, which is 5, and in place of n of A intersection B we can substitute its value, which is 2. So 5 plus 5 is 10, and 10 minus 2 gives us 8. And if you observe this 8 is nothing but the value of n of A union B, right? That means if we add n of A and n of B, and if we subtract from n of A intersection B, we'll always get a value which is belonging to n of A union B. Therefore, we can say that n of A plus n of B minus n of A intersection B is always equal to n of A union B. So that is nothing but the relation between union and intersection when 2 sets are given to us. So if 2 sets are A and B, we can always say that n of A union B is equal to n of A plus n of B minus n of A intersection B. So child, this formula we need to by heart it properly, because next sums which we are going to solve, all the sums are based on this formula. So once again, the formula is n of A union B is equal to n of A plus n of B minus n of A intersection B.